Okay, we're given the graph of a function f of x up in blue on the very top left. We want to use that to answer some questions about this. The first questions we're going to ask about are when y equals f of x evaluated at these different values. So first we have x equals 0, so we're going to use an x value of 0 over here. This question is simply asking which y value, or ordered pair basically, is going to be on the graph. So if we input an x value of 0, we're going to output a y value of 0. At x value of 1, it's going to correspond with this point on the graph, which is right about a y value of 1. All right, and an x value of 2, we're looking at this point at 2. Looks like a y value of 0. At 3, we're at the bottom here, basically. So that's going to be right about at negative 1. 3.5, give or take, is right about here. We're not being super exact. That goes with a y value of 0. At 4, looks to be this point right about here. So we're between 0 and 1. I'm going to say 0.7. And then finally at 5, we're at this point on the graph right about here. And that looks to have a y value of about 1.7. So that you've seen before. It's not really a calculus question. It's more of an algebra, like reading a graph, inputs and outputs type of question. But now we want to think about f prime. The first derivative of this function, it can be thought of as the slope of the tangent line to the curve at any given point. So at an x value of 0, we're looking at the red line going across here. We want to try to estimate the slope of that red line. It's not going to be exact, but we're going to do our best to estimate that. So the slope of this red line, extending it out a little bit, our book goes ahead and says that has a slope of 1. So f prime of 1 equals 1, the slope of that tangent line. Now, when we plug in an x value of 1, we're looking at this horizontal tangent line going across here. Horizontal tangent lines, f prime of 0, happens to have a slope of 0. Right? Rise over run, we go 0 up or down, and then left or right some number. We can do the same at some of these other values. All right, so at 2, we're looking at an x value of 2. This tangent line is going to have a negative slope because the graph's decreasing, you'll notice, corresponds with a negative slope. And give or take, that's going to be about negative 1 for the slope of that line. At 3, we're back at the bottom here. Looks to have a horizontal tangent line, so I'm going to go ahead and say at f prime of 3 corresponds with 0. At 3.5, we're looking at this tangent line. And it's a little bit steeper than 1. It looks like we go from about 3.5. If I drew it in there correctly, it looks like it goes up to about the ordered pair 4, 1. So I'm going to say that has a slope, f prime of 3.5. It's going to be right about 2. At 4, go for an x value of 4. We're looking at this point on the graph. It's this red line going across here. I think we're back down to about 1 for the slope of that line. It's still positive because it's increasing, going up 1 and to the right 1, give or take. And then finally, the very last one, f prime of 5. F prime of 5, x value of 5, you find it on the graph. It looks like this line here. Now, it's still positive. If I try to extend that out, I think that's going to be right about positive 1 over 2, meaning you go up 1 and to the right 2 to find an additional point on this line. It's not exact, but we're doing our best to get pretty good slopes of lines coming out. Now, as far as transferring that into like what's the graph of the slope or the first derivatives graph look like? How I always start these out is I identify when we have a 0 for the slope of our tangent line. That will occur basically at maximums and minimums as we look through it. So at first, start by putting those on the graph of the derivative function. So the slope, I'd start out here at 1, 0, right? The slope is going to equal 0. And then it looked like we had one here at the bottom, right about 3. I guess our graph has it just past 3, but I'm going to say right around 3. It would cross the x-axis also. So like f prime of 3 we said equaled 0. That corresponds with basically this point. I'll stretch it out a little bit there. The rest of them we can kind of fill in. That we said f prime of 0. Sorry, I should have had f prime of 0 equals 1. This point here. F prime of 2 equals -1. We also went ahead as we were listing these out and we said f prime of 3.5 equals 2, so 3.5 is right about here, should be right about 2 on our graph, about the steepest place on our graph there. F prime of 4 was about, let me see, we said f prime of 4 was right about 1. And then f prime of 5 was supposed to be right about 1/2. We may be a little bit low for where 1/2 is on the graph there, but that's the general idea, is get a few basic points going for your first derivative graph. Definitely figure out exactly when the tangent line is going to be 0, right, at maximums and minimums. Get those on the graph first, and then make sure you're understanding that we're going to be above the x-axis whenever a function's increasing and below the x-axis whenever a function is decreasing. That's going to be important if we're ever graphing these. All right, I hope this helps out a little bit on understanding how graphs and derivatives connect together.